So for this problem, we need to find the 6 trig function values of x, of our angle x in the given triangle. So we were given that this is a right triangle with some unknown angle x, and we have a side length attached to the right angle of 1, and then a hypotenuse of 2. So the important thing to remember here is that when you're dealing with your 6 trig functions, if you start with just sine, cosine, and tangent, remember that sine of x is equal to the opposite over the hypotenuse. Remember, we have that term SOHCAHTOA. So sine is opposite over hypotenuse. Cosine of x is equal to the adjacent over the hypotenuse. And finally, tangent is equal to the opposite over the adjacent. And again, just to write that out, that comes from us having the phrase SOHCAHTOA. Opposite hypotenuse, adjacent hypotenuse, opposite adjacent for sine, cosine, tangent. So with all of that in mind, if we look at this angle x right now, sine is equal to, sine of that angle x is equal to the opposite over the hypotenuse. The opposite side of this angle x is the one that's not attached to it. That's right over here. That's this 1. So sine of x is equal to 1 over, and now over the hypotenuse, which in this case is 2. So sine of x is equal to 1/2. Now we need to do the same thing for cosine of x. But cosine of x is adjacent over hypotenuse. And if we look, the adjacent side of x doesn't have a value. So this is where we need to remember that whenever we're given a right triangle, we know that a squared plus b squared is equal to c squared. Meaning if you take the adjacent side and square it and add on the opposite side squared, that's going to be equal to the value of the hypotenuse squared. So if we come back to this cosine of x, we need the adjacent side to find out what cosine is. So the adjacent will be equal to a squared. Sorry, the adjacent is a, and then we're going to square it. So we have a squared plus, and now b squared, we'll say b is equal to this 1. So we get b squared is the same thing as 1 squared. And that's all going to be equal to the value of the hypotenuse squared, which is 2. So we get 2 squared for our c squared. And now we just have to solve for a. So we have a squared is equal to 1 squared is, sorry, I apologize. A squared plus 1 squared is just 1. And that's equal to 2 squared, which is 4. And now if we subtract 1 from each side, we'll get a squared equals 3. And now finally, to get a by itself, we'll take the square root of each side to get a equals plus or minus the square root of 3. Remember, whenever you take the square root of each side, you get a positive and negative answer. But when we just have a triangle floating off in space like this, it's not on a grid, then the sides represent the length of each side. And a length cannot be negative, so we remove the negative answer and just get a equals positive square root of 3, which we can now add into this triangle up here. And now we can find all 6 of our trig function values. So starting with cosine x, now that we know sine of x, cosine of x is adjacent over hypotenuse. So we get adjacent is the square root of 3 over the hypotenuse is 2. So cosine of x is equal to the square root of 3 over 2. Now we need tangent of x, which is the opposite over the adjacent. So the opposite side is this 1 over the adjacent is the square root of 3. But remember, we have to rationalize this. We cannot leave a square root in the denominator, so we'll multiply the top and the bottom by the square root of 3 to get tangent of x is equal to the square root of 3 over 3. Square root of 3 times the square root of 3 is 3, and 1 times the square root of 3 is the square root of 3. Now to find cosecant x, secant x, and cotangent x, we don't have to go through memorizing those ones. The nice thing is that sine of x is the reciprocal of cosecant x, and vice versa. So if you have sine of x, you can quickly find cosecant of x by just taking the reciprocal of it. Since sine of x is equal to 1 over cosecant x, then that also means that cosecant x is equal to 1 over sine of x. So to find cosecant of x, all we have to do is take the reciprocal of sine of x, which is just 1 over 2. Its reciprocal is 2 over 1, or just 2. Now let's do the same thing for cosine of x. The reciprocal of cosine of x is secant x, so we're going to flip it over to get 2 over the square root of 3. And if we multiply the top and bottom by the square root of 3, to rationalize it, we'll get 2 square root 3 over 3 is our value for secant x. And now finally we can do the reciprocal of tangent x, which is the reciprocal of the square root of 3 over 3. But to make it easier, let's go back over here. The reciprocal of 1 over the square root of 3 is the square root of 3 over 1, or just the square root of 3. So you can do this reciprocal at any step, whichever one is the easiest. And this is our solution. These are all the 6 trig function values of x.